Hello, this is Dr. Brown. In this short video, I'm going to be talking about how to calculate local min and max of a function. This is homework 4.3.57. The function we're talking about is f of x equals sine of 6x between 0 and pi over 3. One of the first things I would do is I would graph it. Uh, Calculating the period of the function, which is 2 pi divided by 6, which is pi over 3. So we've got a sine wave with a period of pi over 3, and you can see a graph right here. The next thing we're going to do is calculate the derivative to look for possible local min and local max. The first derivative is 6 cosine of 6x, and that equals 0, and that could tell us where we could have a local min or a max. So in order for it to be 0, 6x has got to be pi over 2 or 3 pi over 2 if you look at your unit circle where the cosine function is 0. And this happens at pi over 12 and x equals 3 pi over 12. 3 pi over 12, of course, is pi over 4. So pi over 12 and pi over 4 could be local min or max. Now, looking at the graph, you can already see that at pi over 12, it's going to be a local max. Pi over 4 is going to be a local min. But if you didn't graph it, you can check the second derivative to see whether or not it's concave up or concave down. Well, the second derivative of the function is minus 36 sine of 6x. And the second derivative at pi over 12 happens to be minus 36 sine of pi over 2, which is minus 36, which is less than 0, which means it's concave down. I usually draw something like a concave down graph to see that that's a local maximum. Now, the second derivative at pi over 4 is equal minus 36 sine of 3 pi over 2, which is plus 36. That means it's concave up and it's a local minimum. So now we know we have a local max at pi over 12, which we can see from the graph, and a local, which means at that particular point, the value is 1, and the local min at pi over 4. And if you calculate that value, it's minus 1. And now we want to look at endpoints. If you look at the graph of f of x, you notice that at this endpoint, that's going to be a local min. And at this endpoint, looking at points away around it, it's going to be a local max. So x equals 0 is a local min, and x equal pi over 3 is a local max also. And then what you do is complete the question by filling in the values that we just looked at. It has a local maximum value at 2 values of x, and the first one is pi over 12, and the other one is at pi over 3, as we just showed. The function has a local minimum value at 2 values of x. The very first one is f of 0 equals 0, and then the next one is f at x equal pi over 4, which is minus 1. And the last part, it asks you to graph it, which I have done here, and obviously the answer is here. And you can then answer the next question, moving across the interval from left to right. F prime, which I've also graphed here, goes from positive to negative at pi over 12, and therefore has a local maximum at pi over 12. That's because it's increasing and then decreasing, which gives you a local maximum, and it changes from negative to positive at pi over 4, negative to positive at pi over 4, which means it's decreasing and then increasing. So that is the homework for homework 4.357.